Okay, all right. Hello, how are you? So today we are going to study about circle. Especially about the properties of a circle. Yeah, what is circle? So before we are going to discuss about the definition of a circle. As we have learned previously in the last meeting, we have learned about points. We have learned about line and square, triangle, and today we learn another form, yeah, another two-dimension form called circle. So what is circle? Circle is when we have fixed point at the center here. Yeah, fixed point. Let's say 1 point at the center, and if we have set of points, yeah, let's say here the set of points, many of points here, and has the each point has the same direction to the center here. So will be if we join the point, yeah, if we joining all the points, will form like this, yeah. So if we have more and more points, so we get a circle here. So this is the circle as here at the center. Here is the center point of the circle, and point around is the form of circle, the form of the circle. Okay. Now, this is what we are going to study, to discuss today about the properties and or the things that we have to know about circle. First, about center. Yeah, we will study about what is center, and second, about radius and about diameter, and circumference, and next arc of a circle, sector of a circle, semicircle. Yeah. So these are the things that we are going to study. So first, let me introduce you to the properties of circle here. Simple circle. Yeah. As we have discussed in the beginning, yeah, about a circle. So circle, as we know, this is the center. Yeah, the center here. So here is the center of the circle, and the distance from the center to the circumference here, yeah, circumference is the form, yeah, like what I said in the beginning, yeah, the collection of a point, yeah, if we have many of points. So if we connect them together, them all will form like this, yeah. So we call it circumference, yeah, circumference. So the radius. So the radius is the distance from the center of a circle to the circumference. So this is the three things, yeah, we have known about circle: the center, the radius, and the circumference. Okay, and next, so we'll study about arc. So arc is a part of perimeter. Sorry, I mean circumference. Yeah, as we studied before. Yeah, as we study here, circumference. So if we take the part of circumference like this, let's say the blue curved line here. Yeah, the blue curved line here. So we take this part. We call it arc. Yeah, so this is the arc, and another could be the arc also, but depends, yeah, depends on the length, yeah. So we call it minor arc if it is smaller, and major arc if it is greater, yeah. Okay, and next there is also sector of a circle, yeah, sector of a circle. Like if we take the arc, yeah, here, let's say from point A to point B, this is the arc, and we connect the line from each point, yeah, from both point, from point A to the center. Let's say this is the radius, yeah, as we have studied before, yeah, before this slide. The distance from the circumference to the center of the circle, we call it a radius, yeah. And this one also the radius, yeah, to from, let's say, the center here, the center point is O, yeah. We need to give the name for each point. And uh, so if we see here the area, we call it sector. This, yeah. So this is the sector of a circle. Yeah, the sector. So we have learned about center. We have learned about circumference. Actually, uh, the other name for circumference, we often say perimeter. Yeah, perimeter. For perimeter equals to circumference. But in circle, we usually use circumference. Yeah, because for perimeter, we may use also in square or in triangle. We use perimeter. Yeah. So I'll continue to the next property here. A semicircle. Yeah. If we have like circle and then we divide into two main part, yeah, with the similar area, yeah, like here, yeah, the sector, similar sector, so we call it semicircle. Yeah, semicircle. Here is the center, here is the center, and here is the, what is this, the radius, yeah, this is the radius too. So next we will study about actually diameter, yeah, but in the topic of lines in a circle. Yeah. So here, lines in a circle can be divided into two main parts. The first one we call it chord, and the second one we call it tangent here. So only two properties about lines. About circle relates to lines. Yeah. First, let's discuss about chord. So what is chord? If we connect 2 points from circumcise, yeah, from any point at a circumcise, let's say here, this is the first point, let's say point A, and this is the second point, let's say point B. So we connect uh, these 2 points. So we have here a line, yeah. So this line called chord here, yeah, chord. And another chord also could be, for example, here another point on the circumference. Let's say here point C, and here is point D. Yeah. So this is another chord. Yeah. And look at this. This one also a chord. Yeah. When we connect point from 2 points, yeah, from circumference, yeah, but through the center. Yeah, actually we call this chord, but very often we call it diameter. Yeah, so diameter is the longest chord. Yeah, diameter is the longest chord. Yeah, from a circle. Yeah, so this is about chord. Yeah, the first line, and this is the property of chord that you have to know. Yeah, like this is the first chord A B, yeah, as I mentioned before, yeah, this one C D. And if we take the line, yeah, if we draw a line from the center, let's say here the center O, point O, so we draw a line to this chord, this first chord. This line, yeah, this new line will be perpendicular to the chord. This is the perpendicular, means the angle is 90 degree here, yeah, perpendicular. So similar to another chord here, if we draw a line from the center to the chord, will be perpendicular to the chord. Yeah. So this is the definition. Yeah. Perpendicular from the center divides a chord into two equal part. Yeah. Okay. I'll continue to another property here, tangent. Yeah. So tangent is when the line, yeah, when a line contact with a circle, yeah, make a contact with a circle. Let's say here line AB, yeah, and make a contact with this circle, yeah. Here is the contact. So similar with the previous properties of chord, if we take or draw a line from the center, let's say here O is the center, and we draw a line to the line, draw a line, yeah, to another line which contact each other. The these two line, yeah, will be perpendicular, yeah. The first, of course, the first line is the radius, yeah, the radius of the circle, and another line will be perpendicular, means it has 90 degrees, yeah, of angle. Okay, so that's about line, yeah, properties of line in the circle. And next, I'm going to explain to you about another properties, which angles in a circle. Yeah, actually, if we talk about angles in a circle, only could be divided into two main parts. Yeah, the first is called indescribed angle. Yeah, inscribed, yeah, not described, inscribed angle. And the second angle called central angle. So what is this? Let's see here. So inscribed angle, when we have here, let's say here the arc, yeah, arc AB, okay, the arc AB here, and I take another line, sorry, another point here, let's say point C, yeah, let's say point C, and I draw line from point A, yeah, A to point C and point B to point C, and yeah, this this will have two chord, right? This is the first chord, yeah, this is the first chord, and this is the second chord. Okay, first and second chord. So inscribed angle is the angle that create from these two lines, yeah, from chord 1 and chord 2, yeah, that, what is this, connect with this arc, yeah, that connect to this arc. Okay, so another angle here, yeah, if we draw another angle, let's say with the same arc here, yeah, with the same arc, that similar with before, arc AB, yeah, arc AB, AB. So let's say the angle here alpha, yeah. So the angle here alpha for point C, yeah, for point C, and the angle here beta for point D, yeah, for point D. Okay, very often we name the angle with alpha, beta, or gamma, yeah, something to name the angle. Okay, what happen if this angle, yeah, this angle has the same arc with this angle? So look at this, yeah. From here, yeah, from this angle, okay, go to this arc AB, and also angle beta goes to the arc AB. So if they are going to the same arc, the angle will be the same, yeah, will be the same, like alpha equals beta. Okay, this is the angle. So this is the actually the definition: angle subscribed by arc AB. Yeah, angle subscribed by arc AB. So subscribe to the arc AB, yeah. Uh, the name, yeah, how to say it, subscribe, yeah, subscribe means connect to arc AB, yeah, that line. So the angle ACB equals to the angle of ADB, yeah. So this is the properties of inscribed angle, yeah, inscribed angle. If we have two inscribed, will be subscribed, yeah. Okay, they will have this the same magnitude of angle. Okay, so what if we have here line the diameter? Let's say here the diameter. So means 2r, yeah, r, and we have another chord here. Let's say at the point C. See, this is the first chord, and this is the second chord, right, second chord. And if we see the triangle here, yeah, it will be the right triangle. It means that has the angle here 90 degree, yeah, the angle of ACB 90 degree. So every angle that has the length, sorry, has the long hypotenuse here. Yeah, if we I review about the Pythagorean theorem, yeah, before, yeah, you know about this right triangle, yeah. So the longest side uh, here, yeah, this is the longest side, yeah, equals to the longest side equals to uh, sorry, the longest side to the power of 2 equals to x to the power of 2 plus y to the power of 2. This is in terms of what is this? We call Pythagorean theorem. Yeah. Okay. So I continue to the properties here. So it will has the angle 90 degree. Yeah. So and next, the second properties here about the angle, we call it central angle. Yeah, central angle. Actually, this one is similar to what we called before sector of the circle. Yeah, sector of the circle. So the angle here, we call it central angle. So there is also the connection between central angle and inscribed angle before. So let's say let's write here another inscribed angle at any point. Okay, subscribe to the same arc. Yeah, let's say a point here, point C. Yeah, this is point C. So subscribe to this uh, arc. Yeah, arc AB. So this is inscribed angle. We will have we'll have the magnitude, of course, yeah. Let's say alpha, and central angle, let's say beta. So these two angle has the connection, yeah. So the connection is the relation is beta, yeah, the angle beta here, the central angle must be equals to twice of inscribed angle, yeah. This one alpha is inscribed angle. So if we have like another here, another angle, another inscribed angle, subscribe to the same arc. Let's say here the angle theta. Okay, theta is the angle. Alpha, yeah, from the previous explanation, alpha must be equals to theta. Yeah, this must be true. Yeah, because they subscribe to the same arc, yeah, which arc AB, yeah. But if we talk about central angle beta, so it will be twice of its inscribed angle, yeah. Up to this point, yeah, hopefully you can understand about these properties, yeah. So I'll continue to another here. Oh, actually, this is the explanation that I have explained to you before, yeah, about the central angle equals to twice of the inscribed angle here, yeah. For example, let's say if we have here the value of the angle here, 60, yeah, 60 degree. So the inscribed angle here must be 30, yeah, half of it. Yeah, because this one is twice. Sorry, this one is twice here. Yeah, the inscribed angle. Okay, yeah. So I have explained this. Okay, so I think that's all about the properties of the circle that we have studied. Yeah, we have learned about the radius, the center, or the perimeter, or the circumference, and we have learned also about lines. Yeah, that contact to the circle, and also line connect from each circumference. Yeah, we call it chord. And also up to this point, we learn about central angle and also inscribed angle, which inscribed angle equals to half of the central angles. So this is the last about the formula, the formula in the circle. To find the perimeter, yeah, perimeter or the circumference, yeah, to find the circumference, we use the formula here to multiply by phi multiplied by r. So what is phi? Phi is the ratio, yeah, the ratio if we compare the perimeter and the radius. Yeah, if I draw here a circle, oh, I'm sorry, my circle is bad. Okay, this is the center. Okay, let's say this is the radius. Okay, radius, and we have here the perimeter. Perimeter is the distance. Yeah, let's say this is the starting point, and then you go through this circle. We call it perimeter. Yeah, in one period. Yeah. Okay. So if we have small circle, big circle, the if we measure the length, yeah, the length of the perimeter manually, and we divide by its radius, we'll have the ratio close to 3.14 something. Yeah, 3.14 something. Yeah, even small circle, big circle, it has the same ratio. Yeah, or to make it easier to be calculated, very often we use this fraction number 22 over 7. Yeah, 22 over 7. So this is the value of phi. Yeah, and to find the length of perimeter without measure it manually, we can use the formula to multiply by phi multiplied by the radius. And if the question here asks for the length of an arc, it's easier. So you just need to find the angle of the arc, and you compare to 360, which mean one rotation. Yeah, if we rotate a circle, it will have 360 degree. Yeah, for example, if here we have the sector. Okay, I draw circle here, and I have the sector here, and I have the sector here, let's say 60 degree. Yeah, I measure by my arc. Yeah, 60 degree. And if I want to find the length here, yeah, the length of arc, let's say arc AB, the length of arc AB. So I only need to compare the angle 60 over the whole rotation. Yeah, 30, 60. Yeah, sorry, 360 degree. So for example, yeah, I write here, yeah, the example 60 over 360 multiplied by the perimeter here, yeah, the perimeter. So if we have 60 degree, the length of the length of the arc of this 60 degree will be 1 over 6 of its perimeter. Yeah, to find the perimeter, we use the formula 2 times phi times r. Okay, so that's the formula to find the perimeter of the circle, or the length of an arc. Second, if we want to find the area of the circle means yeah, the whole area inside the circle. So we use this formula, yeah, V multiplied by R to the power of 2, yeah, VR square. Yeah, V could be 3.14 or 222 over 7. Okay, yeah. And if we want to find the area of the sector, easy too, yeah. You similar with this, how to find the length of an arc. You compare the angle of the sector with 360 multiplied by the whole area of the circle. Okay, yeah. I think that's all about my explanation, yeah, about the properties of the circle. Yeah. Let's go to the beginning here. So here is the beginning. Yeah. We have done everything. Yeah. We know about the center. We know about the radius. We know about the diameter, which 2r. Yeah. We know about the circumference, but very often we call it perimeter, yeah, circumference of the circle. And we know here another property called arc of a circle and sector of a circle. Yeah, arc is the length, yeah, the length of a part of perimeter. Yeah, sector is the area of a part. Yeah, like if you eat pizza and you cut the pizza and it's a small part, so we call it sector, yeah. And semicircle, which mean half of a full circle. Okay, thank you for your attention and may God bless you. Bye.